if there will be closed loops. Okay, so this scheme, the address learning will be effective only when we are talking about a tree topology where there is no closed loop exist. So in view of that, I told you that how a closed loop problem um, can create uh, chaos among the bridges, that in understanding that which port should be used for forwarding the frame, right? So there is a concept of a transparent bridge. What is a transparent bridge? Transparent bridge is one whose existence is not known to the stations. Okay, though it interconnects similar LANs. Okay, always remember the bridge is used to interconnect similar LANs. Similar LANs means the LANs which are using the similar characteristics, similar protocols, right? So the two Ethernet LANs can be joined together. So a transparent bridge is one whose existence or whose presence, okay, whose addition or deletion in the network doesn't affect the stations. Okay, so whose addition, deletion doesn't affect the stations, right? The stations are not aware of the presence of a bridge. So it's like a stations feel that they are directly connected to the network, but there is a transparent bridge. So why it is being named as a transparent bridge? Because when we talked about routing with bridges, right? So when we talked about routing with bridges, we talked about fixed routing, we talked about source routing, and we also talked about dynamic routing. So when we are saying about a dynamic environment where the network conditions are changing very rapidly, in such an environment, right, there may be a possibility that the intermediate device may get down, or some intermediate devices may be added to the network, right? So if that is so, suppose if you talk about a ring LAN, you will feel like that in a ring LAN, if addition of a new device will change the topology, means the structure of the ring, right? It will affect the structure of the ring, but it is not so. The transparent bridges are not so. So there are three conditions that a transparent bridge should conform. The first condition is it should a transparent bridge should perform address learning. Okay, that I have already told you that how the bridge learns with the movement of the frames. Okay, then the second is there should not be any closed loops. Okay, so the redundant bridges should not be there, redundant paths should not be there. So ideally it should be a tree topology, but since we are using in other topologies as well, so how will it work? So we need to draw a spanning tree, right? And the third is basically that frame forwarding. A bridge must have a routing intelligence in the form of a routing table. So, and the bridge should forward the packet, forward the frame from the respective port, okay, to the towards the destination. So bridge should know that which will be the next hop, okay, to which it has to forward the frame. So frame forwarding, except the incoming port, it should be capable to forward the frame in the uh, to the next hop, right? So these are the three characteristics of a transparent bridge should match. Okay, So it should perform address learning. It should learn from the movement of the frames. There should not be any closed loop, and it should forwards the frame based on the routing table. Okay, and it should also update its routing table based on the new routes discovered by the bridge. Okay, because of the movement of the frames, the bridge will learn, okay, whether this station is down, the other station is up. So which route should be followed? So these dynamic tables are updated based on the current network conditions. So that is why it is called as a dynamic routing, right? The routing decisions are made purely based on the current network conditions, right? So that is basically the three characteristics of a transparent bridge. Now we have seen the address learning. You also know that how the bridge is used to forward the frames based on the um, routing decisions, right? So now the thing is that there should not be any closed loop. So to satisfy this criteria, okay, we draw a spanning tree. Yesterday I hinted you a bit about spanning tree. So what is a spanning tree algorithm? A graph which has no loop. Okay, there will be only one path existing from one lane to the other lane, or from one bridge to the other bridge, right? There will not be any closed loop, so that the closed loop problem will come. So how the spanning tree is being made? See, it is important if the exams are going to be offline and if you people are not aware of it, right? I will share some question papers of the previous semesters, right? It will not be that easy to draw and do it everything by your own. So if you are not following the things, right? So please pay attention to this because the exams are going to be offline. That is almost sure, right? So and this is your sixth semester, so you will also not like that you will get bad marks in this subject, and I also don't want that. So please pay attention. Okay, there will be only one path existing to reach from LAN to another LAN, right? So how the spanning tree is drawn? So to find the spanning tree, a cost is being assigned on each path. Okay, cost is being assigned on each path by the network administrator, and each bridge, as I told you, that each bridge is having its own unique ID. Unique ID, that you can say a device ID or a device serial number. Okay, so there are many bridges in the network. All the bridges, then see, I told you that it is similar to a what we are going to do. We are going to make a spanning tree. When I'm saying a tree, there will not be any closed loop. So for a tree, we should start from the root of the bridge, okay, and to the end of the branch, right? So first of all, the root bridge is to be selected. Which bridge will be considered as a root bridge? So how the root bridge selection is being done? All the bridges in the network broadcast their IDs. That is their unique IDs, device IDs, and then the bridge with the smallest ID is chosen as the root bridge. So once the root bridge is selected, okay, we find out the path to reach from one LAN to another LAN, or from the root bridge to all other bridges, okay, with the smallest path, with the smallest cost, okay, with the smallest cost, we find out the path from the root bridge to the other bridges, and there will not be any closed loop, and wherever, as the bridge is a multi-port device, okay, so there will be multiple connections, there will be multiple loops. So how the loops will be prevented, we will see with the help of an example, right? So the algorithm tries to find out the shortest path from the root bridge to all other bridges in the networks or LAN, and that will be based on the total cost from the root bridge to the destination. So the shortest path will give you the shortest tree, and so based on the spanning tree, some of the ports which are participating in forwarding the frames will be kept as it is, while some of the ports will be blocked, which are not necessarily required, right? So some of the ports will get blocked. So suppose this is the architecture. Okay? This is our network topology is given to you. This is the spanning tree I have drawn. This is our network topology is given to you, right? You can see here a closed loop exists. From here you can go back to here, you can go back to here. So closed loop does exist, right? So first of all, I will tell you some of the things that you can see that there are 4 LANs. Okay, LAN 1, LAN 2, LAN 3 and LAN 4, right? If you are not following, please stop me and ask. And this is what it is shown the cost. The C equal to 10, and at each bridge you will find a cost is marked. Okay, a cost is marked. This is a cost to forward the frame from bridge to the LAN. Okay,
So both cost has to be same, or it can be different.
it can be
Like
different also.
C10 and C10.
It can be different also. It can be different also. It will depend on the network administrator, right? It will depend on the network administrator. Maybe like कभी-कभी होता है ना कि like we go with one path, right? यहाँ से like suppose if you are traveling from Ranchi to Delhi, okay, the train moves on the same way, but you will find that there will be some kilometer difference comes in the same route even. So the same way the cost can be different, and the cost, see how the cost will be decided, right? The cost will be decided. Suppose if you do not want that the more traffic should be routed through this, right? So what you will do? You will put more cost on this. So obviously the traffic will be reduced on this, right? So it is decided by the network administrator that what will be the cost. Okay. So suppose there are 2 important things that you should note here, that the cost is always from bridge to LAN. When you are forwarding a packet from bridge to LAN, there will be a cost. Suppose if you are forwarding a packet which is coming from LAN 2 and you are forwarding on this LAN 1, so the cost associated will be this. But there will never be any cost from LAN to bridge. From LAN to bridge, the cost will be 0. Okay, so from LAN to bridge the cost will be 0, and from bridge to LAN the cost will be this cost, right? Now there are different bridges, as I told you, to draw. Pardon?
So where is the cost 0?
When you are moving the frame from LAN to bridge, suppose you are on a LAN, you are saying from LAN to bridge this cost is 0, and then once the bridge forwards this frame onto LAN 2, this cost will be used, right? We are seeing just we are seeing. So first of all, to draw a spanning tree, what is essential? It is essential that first of all the selection of the root bridge is to be made. Okay, so since here there is no provision to see the unique IDs of the bridge and other things, so basically we assume that we assume that bridge B1, or we select bridge B1 as the root bridge. Don't see on this side. Okay, first let us try to do it by our own. So let us see bridge B1 as the root bridge. Okay, so since bridge B1 is the root bridge, what we have to do, we have to find out, okay, that how we can reach from this using this bridge to other LANs, okay, or other bridges. So suppose if I choose bridge B1 as the root bridge, it is connected to LAN 1 and LAN 2. Okay. So suppose if I have to go from using bridge one, there are two types. One, it can be a source bridge, another it can be a destination bridge. Okay, so it depends whether it is a source route bridge or it is a destination route bridge. So if I select it as a source route bridge, okay, if I select it as a source route bridge V1, how will you reach? Suppose you want to you want to go to LAN 2. LAN 2 is, there is no other way. Okay, you will direct, what will be the cost to reach LAN 2? 10.
10.
Okay, suppose if you want to go to LAN 5, how will you go?
From LAN
Which
2,
bridge?
then bridge 4. Bridge 4.
10 और 5 15. Okay, so there can be a tie also. Suppose you will be taking this route. So from bridge B1, if I am going to LAN 5, 10, or if I use B3, 10 plus 10 20 होता है ना? So this is 20. I can say this will be 20 from here to here. It will be 20, and from here to here it will be 15, है ना? And from here to here is also, you should see, this is also 15. Okay, so now there is a tie. There is a tie between bridge B5 and B4. Okay, so there is a tie between these two bridges. So which bridge will be selected as a route bridge? Okay, so generally we select the smaller ID bridge we keep. Okay, whenever there is a tie, okay, the path with the smaller bridge ID is retained. So B4 is the having the smallest serial ID as compared to B5. So B4, this path will be retained while this path will not be followed. Okay.
Sir, if in some case the cost is same, but the number of bridges we are passing is more, should we choose the path with minimum number of bridges?
No, no, it will be mentioned to you. See, in that case, if you have to select a path with minimum number of bridges, then the cost will not be associated there. Either one criterion you will be using, either you will be using the minimum number of hops or the minimum cost, right?
Okay.
Both the things will not be together. So either it will be minimum cost or minimum number of hops. Okay, so that the thing which you are mentioning is based on the minimum number of hops, right?
Yes, sir.
So in case of tie, a bridge with smallest ID is chosen. Right? So that is why you can see that this is connected to LAN 1, this is connected to LAN 2, and I am going to bridge LAN 5. Okay, how I am going to LAN 5? I am going to LAN 5 using LAN 2, then B4, and this is LAN 5. Okay, so can you say how will I go to LAN 3?
So via bridge 2.
How?
LAN 1, then LAN 3.
Bridge 2,
LAN
LAN
1,
3.
C10, and 15. Total cost 25.
25 कैसे होगा?
B1 to LAN 1, 10. Okay,
देखो
LAN
मैंने
2,
आपको क्या
bridge is 0. Yes, sir. So 15.
15 होगी ना, 15 होगी.
Yes, sir.
So we will go from LAN 1 to B2, B2 से LAN 4.
B2 से LAN 4.
अच्छा 15 और ये LAN 5 और LAN 4 और LAN 3 तो यहीं पे हो गया, ये दिस इज LAN 3 एंड LAN 4 ऑल्सो सेम 15 है ना.
Yes, sir.
So now you see that you have reached all other LANs. So you can see that this bridge B5, okay. So you are not using this bridge B5 to move from this to this. LAN 5 में जाने के लिए आप इसको यूज नहीं कर रहे हो ना, because you are going LAN 5 using bridge B4, right?
Yes, sir.
Similarly, this bridge B3 is also not used to go to LAN from LAN 2
LAN
to
5.
LAN 5. It is also not joining, right? So these ports will be blocked. So अब आप क्या करोगे? This is connected to LAN 1, but this port is not allowed to forward any frame. So this port will be blocked. Okay, you can show like this that this port will be blocked. Okay, and similarly B3 which is connected to LAN 2, this port of bridge B3 is also blocked. So you can show it either by the dotted lines, right? Either by the dotted lines, this is LAN 5 only, or you can mark like this as a blocked port. Okay, clear है ये? अगर you may not, this is a very simple network, right? But when a network will be given, there will be more number of bridges, a more complicated, more number of redundant paths will be there, right? So you have to keep you have to check very cautiously that there are multiple route exist and how the route with the shortest path should be chosen, right? I hope the idea of drawing a route spanning tree is clear.
So
is it
how
not?
is it drawn? Like, what do we have to cross?
See, you just see that this port bridge B5, okay, bridge B5. Good thing that you are asking this. Bridge B5 is not, are you using bridge B5 to forward any frame from this LAN 1 to LAN 5?
No, sir.
No, because we are going to LAN 5 via LAN 2 using bridge 4, right? So this bridge port can be blocked. LAN 1, so this port can be blocked. Either you can show that this port is blocked, or you can show that this port is blocked. Okay, so that the movement will not be there, so there will not be any closed loop. Okay, so generally students mistakes क्या करते हैं? They leave the closed loops. जब वो draw करते हैं तो there will always be a closed loop में छोड़ देते हैं. तो spanning tree का फंडा ही है, the spanning tree is drawn to get free from the closed loops. Okay, there should not be any closed loop. So you should be careful while drawing the spanning tree that there should not be any closed loop. So either you can block this port, right? Because, or this port, any port you should block so that the closed loop should not exist. Similarly for B3, either you block this port, or if you are connecting from this side, you should block this port so that a closed loop should not exist. So you can see here in this diagram, there is no closed loop exist, right? There is no closed loop exist. So there is only a single path to move from this to this, right? Now,
Yes.
there are some definitions, right? So root bridge, see why it is referred to as a source root bridge, because you will be reaching from this bridge to all other things, right? When I will say the destination root bridge, this bridge will be the last, right? You have to reach to this bridge from your LAN to this, from this to this, right? Because the root bridge can be a source from where the branches are moving up, or it can be a destination where the branches are terminating. Okay, so it can be viewed in both the ways. So it can be as a source root bridge or destination root bridge. So you can draw like that, right? Now, what is root bridge? You know that the root bridge is nothing but the bridge with the smallest ID. is called as a root bridge. I will provide the photocopy of all these things. I will upload it in the Teams. Okay, books
Sir,
from
in
the book.
case of destination root bridge,
Uh,
so how will we draw the spanning tree? Like B1 is the destination, so all bridges should reach to B1, right?
right. So the ports like from this LAN, okay, the ports will be blocked. How you will count from? How will you reach from LAN 4 to bridge V1? Okay, so it will be from this LAN 4. It will be from LAN to bridge. It is cost 10. So it will be 10. Okay, or which path you should choose. So I will give you two examples, right? I will upload it to questions. Okay, you do it and we will discuss it with their solutions. Okay, in the next class.
Okay. Okay.
I'll give you a complex problem. I will see some question paper and will give you. Okay. So idea is same, that here what we are doing, we are reaching from B1 to everyone, and in that we will, because the cost will be different now, because here the cost is same. You can see the cost, the question which you asked, that you have chosen the same cost. So if the cost is different, okay, if I put this is 10, this is 15, right? Or this is 10 and this is 15, what will happen? When I'm moving from bridge B1 to LAN 4, the cost is 10 plus 5, 15. But when I'm moving from LAN 4 to bridge to this LAN 2, what will be the cost? 10 plus 15, 25. So the cost is different.
Yes.
So that makes the difference when you are taking as a source root bridge or the destination root bridge, right?
Okay, sir. So in destination root bridge, all other bridges will be source bridge.
Yeah, from that bridge, it will terminate at this bridge B1.
Okay, sir.
And we will show. So generally, why I have marked this kind of port, because when we are saying from bridge B1, okay, why I have chosen this way, because we are moving from, because bridge B1 is the source bridge. Okay, so this part will be blocked and this port will be blocked, right? Because any one path should exist when we are moving from bridge B1. So root bridge, you understand what is root bridge? What is the root path cost? There are some other definition. What is path cost? Path cost is like the cost associated with each bridge. So suppose you are moving from bridge V1 to LAN 4, right? From LAN 2 to LAN 4. So the path cost will be 10 plus 5, 15. The total path cost will be 15 total cost associated from LAN 2 to LAN 4. So that will be the path cost, right? Root port, all the ports of the bridge which are towards the root bridge are called as the root ports. So they are marked with root ports. Are you following? This is the bridge B5. This port of the bridge B5 interconnects it with the root bridge. So this will be called as a root port. This bridge, this port of the bridge connects it with the root bridge. So this will be called as a root port.
The cursor is not visible properly.
Okay,
the below
okay.
one, right? B5 below one.
B5 up now is it visible?
Okay. Yes, sir.
So this port of the bridge B5 connects it with the root bridge. No. So this port forwards the frame towards the root bridge. So this will be called as a root port. Similarly for B2, this port which connects it to the root bridge will be termed as a root port. Similarly for B4 also, this will be called as a root port, right? Which
Yes,
the
sir.
port of the bridge which connects it to the root bridge is called as a root port. Root path cost. Root path cost means, from, suppose you are moving from this LAN 3. So what is the root path cost? Means to reach to the root bridge, what is the cost? Okay, to the cost associated in reaching the root bridge is called as a root path cost. Okay. Designated bridge, designated port. So this port of the bridge, this port and this port is called as a designated port, and this bridges which interconnects directly to the root bridge are called as a designated bridges. Okay, and these ports from the LAN which forwards the packet towards the root bridge is called as a designated ports. हर एक LAN का एक designated port होगा जो कि root bridge की तरफ जाता है. हर LAN का every LAN has a port. Every LAN forwards a frame to a port which forwards it towards the root bridge is called as a designated port for this LAN, designated port for this LAN. Okay, and this bridge will be called as a designated bridge for these LANs. Okay.
So in root path cost, we see from reaching B5 to B1, right? Reaching to the root cost, right?
From anywhere to from anywhere to to the root. Root path cost is for each bridge. The cost of the path to the root bridge with minimum cost. Okay, from each bridge, the cost to reach to the root bridge is called as a root path cost. And designated bridges are and designated ports are for each LAN. One bridge is called as a designated bridge. One bridge is chosen to be as a designated bridge because यहाँ से जो भी ट्रैफिक निकल रहा है वो कहाँ जा रहा है, B2 में जा रहा है. So B2 is the designated trip, the designated bridge, and this port which is being used by this LAN 3 will be termed as a designated port, right?
Yes. So in this example, if we are using B1 as the source root bridge, then the root path cost may or may not be minimum, right? From B5 to B1, we may not have chosen the correct path for the root path cost. Because for the root path cost, B1 should be destination root bridge, right?
Yeah, but you can count from here also now. From this bridge B5, you will be going to LAN 1. What is the cost? 5 now. 5 plus. So the cost is 5 only.
5. But in this case, we see it as 5, right? No. Okay.
The root path cost means from the cost of the bridge to the root bridge will be called as the root path cost, right?
Okay, sir.
There is a path cost. That means when you are moving a frame from one LAN to the other LAN, that will be a path. Okay. So now I hope it is clear. I will give some examples. I will share some old question papers in that some spanning trees are given. You can draw it, practice it, and answer I will say. If you first show me, and then I will show the answer also, where exactly whether you have done correctly or not. So now I am moving to the last topic, that is we have already discussed the connecting devices. What is their role of connecting devices? So we discussed the bridges. Bridge is a MAC layer device. It forwards the frame at the MAC level. Okay, bridge performs frame handling at the MAC level. Okay, so as compared to the bridge, there is a layer 2 device. So layer 2 device means it also works at the physical and data link layer. It is called as a data layer 2 device. What is the difference in a layer 2 device and a bridge? That the layer 2 device, basically what is the difference in bridge and layer 2 device? So bridge performs frame handling in software, while this layer 2 device performs frame handling in the, because it is a switch, we termed it as a LAN switch. Okay, so so it performs the address recognition and frame forwarding functions in the hardware. So it is much faster than the bridge. Second difference in a layer 2 switch and the bridge, that a bridge works only in a store and forward fashion. What the bridge does, bridge copies the entire frame and then forwards it on the designated port, right? So it works in a store and forward fashion, but the layer 2 devices have two options. One is a store and forward, where the complete frame will be copied and then it will be switched, because it is a LAN switch. Then it will be switched on the designated output port or output device, right? On the other hand, there is a cut through switch, which takes the advantage of the fact that the address, the source address, destination address appears at the beginning of the frame, right? If this is a MAC frame, so it appears at the beginning of the frame. So it, rather than copying the entire frame, it copies only the beginning of the frame, only this portion, the address portion it copies and performs the frame forwarding based on that. So obviously it is much faster than the store and forward option, right? So, but what is the disadvantage of this cut through switch? Because the CRC, where a frame check sequence, which checks whether there is any error in the frame, so it doesn't check for that, any error in the frame. And in what are the consequences of that? That it sometimes forwards the corrupted frame in the network, right? So that is a disadvantage of the cut through switch. Though it improves the throughput, it is faster, it can forward more frames at a time as compared to a store and forward operation of the layer 2 device. But there is a possibility that it can also forward the bad frames in the network, right? So if I compare LAN switch or the layer 2 switch with a bridge, so the comparison that the bridge handles the frame in the software, the LAN switch handles the frame address recognition and frame forwarding in hardware. Second difference is that bridge performs only a store and forward operation, right? While the LAN switch performs store and forward as well as the cut through switch option, right? Then the third is the third difference is that and that is the most significant difference, that as I said that bridge performs frame handling in software. So bridge can handle only one frame at a time, right? Once the one frame arrives at a port, it copies it, checks, performs the address recognition from the routing table, and then forward it on the desired port. But if I say a LAN switch, you have seen that how the LAN switch improves the throughput, that multiple devices can communicate, because LAN switch is just like you can say a switching hub, right? You have seen it in the star topology, it is a switching hub, right? So once on any incoming line the frame is coming, okay, it switched it onto the outgoing line. So it is just like a switching hub, so it can handle multiple frames at a time, and that makes the difference in layer 2 switches and bridges, right? So a LAN switch is having higher performance and can incorporate the functions of a bridge. Okay, so bridges suffered commercially, right? But the layer 2 switches have two disadvantages associated. Two potential problems are associated with the layer 2 switches. The first problem is, as we have discussed, that when there will be multiple redundant paths, right, there should not be any closed loop. Okay, there should not be any closed loop, or you can say there should be a single path between source and destination pair, right? So if any failure is there, okay, if one path fails, then the traffic will be blocked. Okay, so there should be a single path between a source and destination pair. So failure of a switch will block everything. Then a flat MAC address results in broadcast storm. Flat MAC address means like suppose if a layer 2 device is malfunctioning, okay, and flat MAC address, जैसे आपने देखा ईथरनेट में हम लोग क्या करते हैं, 48 बिट को 1 कर दिया, that means it is a broadcast address. So if a device, if a malfunctioning device which uses a flat MAC address, okay, and if it is malfunctioning, what it can do, it can simply start broadcasting frames to broadcasting frames. So what will happen? It will create a huge traffic in the network, right? So how these two issues can be dealt with? The solution is, as you can see, that the root bridges can work only in can interconnect only similar lanes, right? So layer 2 switches also are same thing in the hardware option of the bridge, you can say, right? So how to deal with these issues? First of all, we need, because you are not always confined to interconnect similar lanes, right? You like to connect with different vendors, right? So in such scenario, we require a device named router, right? Router can solve our all these issues. How interconnects dissimilar lanes? The issue with there should be, what the router does, you can divide the network, you can, the whole network can be divided into different parts and can be interconnected with the routers, okay? So once you are doing it, even though if some device is malfunctioning, right, this broadcast will be limited to only a single network. It will not be to all the, it will not create a issue for the complete network, right? It will be only limited to a portion, right? Because we have interconnected the uh, different parts of the LAN using routers, okay? And this issue will also be solved because uh, so it's a 3-layer device. Router is a 3-layer device. It works, it functions using the IP addresses, okay? So router works on IP addresses. It is implemented in software just like bridges, okay? So router interconnects uh, similar lanes, dissimilar lanes, okay? So how the router works? It has the following advantages: that the network may use any addressing schemes. Okay, you are connecting one with Ethernet with a token ring. They may have a different addressing schemes. Okay, um, so maximum frame sizes may be different because the router is capable of fragmenting the frames. Okay, interfaces, the hardware interfaces and software interfaces to various networks may be different. So the concept of router is independent of those difference. Reliability, that it provides more reliability. Okay, being an IP network layer device provides more reliability. Okay, uh, because it can provide its service using a virtual using an end-to-end virtual circuit for over an unreliable service, right? So so the routers, okay, so routers also, it's a 3-layer device. They overcomes the drawbacks of the layer 2 devices, and there is a, but they are implemented in software. So even when they are implemented in software, the hardware version of layer 2 layer 3 devices or the LAN switches, which operates at the 3 layers of the network, physical, data link and network, layer 3 switches, can pump more packets as compared to the routers, because routers are performing the things in the software while a layer 3 switches are doing the same thing in the hardware. So they are capable of pumping more packets in the network within the same time frame, right? So because of its hardware implementation. And there are two types of layer 3 switches. One is packet by packet switch, another is a flow based switch. So packet by packet switch is a like every time a packet comes, the router will check its source and destination address, IP address, source IP address and destination IP address, and will forward the frame based on the that. Another is called as a flow based switch. See, this flow based switch is a key in the internet to provide the quality of service. How do we get this much now when we watch online movies and other things? How do we get पहले आपने देखा होगा कितनी देर वो ऐसे ऐसे घूमता था, right? इंटरनेट में. Now how it is being done, how we are getting a quality of service over the internet. The internet is an unreliable service, right? It doesn't guarantee the delivery of packets, even whether it will be surely delivered. So how it works, how the things becomes better because of the introduction of a flow based switch. First of all, what is a flow? I can say that a flow can be termed as a group of packets. Okay, a group of packets generated by the same source. Okay, and to be delivered to the same destination. Like you can consider it like a you have booked some package for travel. Okay, so along with you there are many other travelers who have also booked the same package. So what the travel agent does, it takes all the travelers in the bus, it put them all in the bus. Okay, because your package is fixed that where at what will be served in the breakfast, what will be served in the lunch, where will you stay, right? So that means you will be all the travelers are getting the similar treatment. Okay, because your journey is fixed, you will be going from Delhi to Kashmir, your journey is fixed, your treatment is fixed, that what kind of treatment you will be getting during your travel, right? When you are moving from Delhi to Kashmir, what will you eat, how will you go, via bus, via car, okay, or via flight. So everything, the treatment to be given is fixed and your destination is also fixed. So you may assume that what is a flow means that a group of packets generated by the same source and to be delivered at the same destination, and during their transit in the network, they require the similar facility. Similar facility means like similar treatment. Similar treatment means a flow. Flow, basically each routers also maintains a flow table. What is a flow? Flow means, right? Suppose some application may request that not a single packet should be dropped. I want no packet drop. Okay, so that characteristics will be there in the flow packet header, that will be mentioned. The flow number will be mentioned. So router will check only the flow number, that where it should be forwarded. So once it checks, so rather than forwarding one packet at a time, it forwards many packets together at a time. So that speeds up the thing. So what is basically a flow? How a flow is defined? Flow is defined based on some characteristics required by the application, right? What could be the characteristics required by the application? Like some application may state that they require minimum delay, that their packets should not experience any delay in the network, right? So the routers will check the flow number, will forward it directly all the packets, right, based on the flow table, that where exactly they should be forwarded. So that gives a kind of a special treatment over the internet. Okay, so that makes the things more proper when we talk about quality of service over the internet. Right, so this finishes the first module, right, and the quiz will be on Thursday. Okay, there will be 20 questions from module 1 of 0.5 each, right? So I will forward some of the material to the team. I will upload it. You can study. And there is one class, I think tomorrow. नहीं, थर्सडे को ही होगा क्लास. तो अगर कुछ डाउट होगा तो आप थर्सडे को पूछ सकते हो. राइट? एनीथिंग यू वांट टू से? Okay then, thank you.